In this video, we'll be looking at using a reference angle, which is from the unit circle exercise. So what is a reference angle? Well, a reference angle is always located in quadrant 1. So you can think of it as being an acute angle from 0 to 90 degrees. It is found by matching the angle distance from the x-axis. The sign, whether it's positive or negative, is decided by the quadrant and the trig ratio used. So let's have a look. We firstly got sine 330. Now our steps had said it is found by matching the angle distance from the x-axis. So we have sine 330 here. Let's firstly draw that in. So we always start at our positive x-axis. Then we rotate around the origin, which is here, until we reach 330. Now I know that is going to be 30 degrees away . So theta is equal to 330 degrees. I know that's going to be 30 degrees away from the x-axis. Do you see how I'm found it by matching the angle distance from the x-axis? And that's the closest x-axis. So I put in here 30 degrees. Well, what does that mean? Well, what that means is then we can find our reference angle in quadrant 1. So here's quadrant 1. So I'm going to draw exactly the same line, but in quadrant 1. So I'm mirroring that value. Whatever the angle is between the x-axis, I copy. So I also write 30 degrees here. Now that we've done that, we need to go, okay, I can say that sine 330 degrees is actually equal to sine 30 degrees. What that means is sine we know is the y ordinate, and I'm saying that distance here is the same as that distance there. But you may note one thing. If I find the y ordinate for sine 330, this is a negative y value, whereas the value for sine 30 is going to be a positive y value. So we know that they're equal in magnitude, but one is opposite the other. So to account for that, we say that sine 330 is in a negative quadrant, and we're going to a positive quadrant. So to make our positive sine 30 negative, we put a negative sign at the front. Think of it as if my sine is in a positive quadrant, I leave it. If my sine is in a negative quadrant, 3 or 4, then I turn it into a negative. The next example is cosine 162. We do the same thing. We start off at our positive x-axis and we rotate round 162 degrees. Now, one thing we can note is that we know that cosine is positive here and here, quadrants 1 and 4, and it's negative here and here, right? So just one thing to know. Now, we need to find the distance between the closest x-axis. In this case, we could go this side, the positive x-axis, or the negative x-axis. So let's take the angle to be the negative x-axis. Now, what would this angle be? Well, it needs to make 180 degrees. This is a supplementary angle. Therefore, this would be 18 degrees. So I can say cosine 162 degrees is equal to cosine 18. So I'm just using whatever that angle is closest to the x-axis, like over here. Then I need to decide, is cosine 18, do I have to make this negative or positive to match cosine 162? Cosine 162 is negative because it's cosine and that's our x value. We can see here that the x value will be like nearly negative 1, right? So negative 0.8 or something like that. So we know that it has to be negative. Cosine 18 is over here, which is positive. Therefore, we need to change that into a negative. The very last example is tan 230. So tan 230 works like this. We start at the positive x-axis as always. Then we need to rotate 230. Now, tangent. we know tangent is essentially like a gradient, right? So tangent is positive in this and this quadrant, because see how that's a positive gradient? Whereas a negative gradient would be there, anything in here would be a negative gradient to the origin, and so would here, coming out of the origin. So therefore we can say positive, positive, negative, negative. Our next step is to find the distance between our line we've just drawn, our array, and the nearest x-axis. So we can see here, it'll be this. Now we've gone 230, which is 180 plus another 50. So this would have to be 50 degrees. We want to match this into our quadrant 1. So the reference angle is going to be over here, and we say this is going to be 50 degrees. So we can say tan 230 degrees is equal to tan 50 degrees. And do we have to change it to be negative? Well, we know that quadrant 3, tan is positive. Therefore, we know that tan 50 is going to be the same magnitude as tan 230, and also they're the same sign. So we don't have to change anything. Now, I'm going to do the your turns. Can you please complete these 3 in your workbooks, and then press play to confirm you got the answer right. So sine 310 Good, how are you?
Not too bad, mate.
So it'll be 50 degrees here.
What's that? Oh, sorry.
And let's have a look at that. So now we need to find our reference angle. Now our reference angle is found by matching that and putting that there. And we know that this will be the same angle. So 50 degrees. Now it's a reference angle because it's in quadrant 1. So we can say that sine 310 degrees is equal to sine 50 degrees. Now, is it positive or negative? Well, let's have a look. Let's put sine positives. So we know sine is positive in the y, when y is positive. So these quadrants, 1 and 2, it's positive, and then 3 and 4, it's negative. So that means sine 310, so sine 310 would have to be negative, because we can see that y value is going to be below 0. So it's going to be like negative, looks like negative 0.7. So we're going to have to make that negative. Next one, cosine 126. Start at the positive, go around until you reach that. Put a dot there, then figure out the distance to the x-axis. In this case, it will be 54 degrees, because we know 54 plus 126 is 180. Our reference angle then is going to be over here, and it will be 54 degrees. Now, cosine is positive for the x values. X values are positive here and here, and they're negative here and here. So therefore we can say cosine 126 degrees is equal to cosine 54, but we know it has to be negative, because we can see that cosine 126 with this angle here is going to be a negative value, and cosine 54 will be a positive value. They're going to have the same x value, but we need to make cosine 54 negative to make it equal cosine 126. Last one we have is tan 260 degrees. We start here and we rotate around until we've reached that value there. So just 10 degrees off 270. I write in 260 degrees, and then I consider what angle this could be. Well, we know it's 180 degrees here. This would be 260, so therefore this must be 80 degrees. So I'm going to draw in that arc there, and that'll be 80 degrees. Our reference angle, therefore, is going to be the same thing, but in our acute or quadrant 1. So we can see in quadrant 1, it's 80 degrees. Now let's consider the tangent function. We know it's positive in quadrants 1 and quadrants 3. And we know it's negative in quadrants 2 and quadrants 4. So if we had to write out tan 260 degrees, we're going to say it's equal to 1080, and that gets its magnitude, so they're the same gradient. We can see that through my dodgy diagram. And is it going to be the same sine? Well, tangent is positive here and positive there. Therefore, tan 260 is equal in value. It's also equal in sine. And tan 80 degrees, that's positive, and so this is positive. So we don't have to change anything. And that's our final answer. Hopefully you got those ones correct. PM me if you need any help. Cheers.